Okay, so this is the second video in a series on the binomial theorem for pre-calculus. In the first video, we kind of looked at some what we called combination numbers or choose numbers and Pascal's triangle. So make sure you watch that video first. So we're going to work through just 6 examples here of combination videos or choose numbers. And I'll do some using the formula. Again, the formula is given right here. I've highlighted it in green. You can also get these on your calculator, though, with the combination button. But okay, 5 choose 2. So you can think of this as having 5 friends, and how many ways can you pick 2 of them? It's top number factorial over bottom number factorial, and then subtract those 2 numbers factorial. So again, this is, if you look at this, this is, the top is 5, 4, 3, 2, 1. But that'll cancel with the 3 factorial, which is 3, 2, 1. So a lot of times you can kind of skip that step. That you're going to have all kinds of canceling. And don't forget 2 factorial, we haven't taken care of that. 2 factorial is just 2 times 1, which is 2. And if you look at this, the top is 20, the bottom is 2. This is 10. So 5 choose 2 is 10. Or again, on your TI-84 graphing calculator, you could type this in. And again, the keystrokes are math, PRB. You toggle over to PRB and 3. That would be the button on your calculator, at least on a TI-84. It just so happened that 5 choose 2 was 10. There's, it has nothing to do with 5 times 2 equaling 10. Second one is 6 choose 3. Now 6 choose 3, we kind of did this earlier. This was the warm-up problem from this page, but you can actually see right here in Pascal's triangle. If you go down, it's actually the 7th row in the triangle if you count the first one as 1. But 6 choose 3, everything's off by 1 in Pascal's triangle. So you actually have to go to the 4th number over, which is 20. 6 choose 3 is 20. When numbers are small, and I'm doing a lot of these, I just look into Pascal's triangle. I think it makes it a lot easier. Again, 6 choose 5. Look at Pascal's triangle. It's obviously 6. But just to show you the formula, what would it be? It would be top number factorial, bottom number factorial, and the difference factorial. And again, this is, the top is 6, 5, 4, 3, 2, 1, and the bottom is 5, 4, 3, 2, 1. Everything cancels except the 6. So, the math is pretty easy with this stuff, okay? Now, 11 choose 9, I don't feel like writing out 12 rows of Pascal's triangle. You're certainly welcome to do it. Again, this is something I do on the calculator or quickly just work through the formula. 11 factorial, 9 factorial, and then the difference factorial. And again, I take the number on top and the bigger number on the bottom. And if you divide them, all you're going to get is 11 times 10, because 9, 8, 7, 6, 5, that's all going to cancel. And then all you're left with is this 2 factorial, which is 2. And here you get 55. And again, as a practical problem, if you had, I keep going back to the friends example, but if you had 11 friends and you could only invite 9 to dinner, you'd have 55 different choices to make there. If you get theoretical, you really have to use the formula. So we got n plus 1 factorial over n factorial. Now the difference, top minus bottom, you just get 1. So when you subtract, you get 1. So that'd be 1 factorial, which of course cancels out. So, what do you really have here? The top, n plus 1 factorial, will be n plus 1 times the number just below that, which is n, times the number below that, n minus 1. And it just keeps going all the way down, till you hit 1. What do you get in the denominator? Well, you get n factorial, which is n times the number below, which is n minus 1 times n minus 2, all the way down to you finally get to 1. And of course, you got a ton of canceling. All of this stuff cancels. And what are you left with? Just n plus 1. So what does that tell you? If the top number is 1 more than the bottom number, you just get the top number. So as an example, 8 choose 7 would just be 8. That's kind of what that means. Finally, if you get the same number on the top and the bottom, like 6 choose 6, or 5 choose 5, or 4 choose 4, guess what? There's only one way to do it. If you have 12 friends and you can invite 12 to dinner party, there's one way to do it. Just invite all 12. Okay, so that's about all I can tell you about these choose numbers. And we're going to get, in the next video, we're going to get really into the binomial theorem. So check out the third video. Take care.